Hello, what's the formula for GPE? It's mgh, right? Everybody knows that, but can you prove it? So this is what this video is about. So let's have a block, mass m, resting on the floor. So if I apply a constant external force, let's call it F external, then I'm able to lift it up through a vertical height of delta H. Using the concepts of work done by forces, I can write this down, right? So the work done by the external force, which is F external times delta H, goes into the increase in KE and the increase in GPE of the block. Now I want to imagine a scenario when the gain in KE is 0. In other words, what should the magnitude of the external force be in order for the block to not gain any speed? The answer is mg, right? Because if external force is larger than mg, then it's going to accelerate as it goes up. If the external force is less than mg, then of course it doesn't even get lifted up, yeah? So if we choose the external force to be exactly equals to mg, then the work done by the external force doesn't change the KE, and therefore all the work done by the external force goes into changing the GPE. So the change in GPE is mg times the change in height. If you stare at this long enough, you should be convinced that GPE should be exactly equals to mgh. Now I know many students always ask, shouldn't the external force be larger than mg? Because if the external force is exactly equals to mg, isn't net force 0 and therefore the block just stays there? So let's think about this, yeah? So let's say the weight is 10 newtons. So what should the external force be? Should it be 10.1 newtons? Nah, I think that's too large, yeah? 10.01 newtons? Nah, I think we can do with 10.001 newtons, right? Then why not we do with 10.001 newtons? You get the idea? It's actually not wrong, yeah? To say that the external force should be equals to mg, instead of insisting that it should be mg plus some tiny little amount. Because that little amount is meant to be 0. By thinking of it as 0, it makes our life so much easier. Okay, so the derivation itself is simple enough, but I want to point out something that's quite subtle. The work energy theorem in its original purest form actually doesn't have the concept of GPE. So when you calculate the net work done, you got to include the work done by every single forces, including the gravitational force. So the work done by the external force and the work done by the gravitational force cancel each other out. That's why the block did not gain any KE. But if you were to incorporate the GPE concept, then when you calculate the net work done, you must not include the work done by the gravitational force. So all you have is the work done by the external force. So the net work done is not 0 this time. The net work done is the work done by the external force, which goes into increasing the GPE of the block. Basically, if you do not want to include the GPE concept, then you must include the work done by the gravitational force. On the other hand, if you want to incorporate the GPE concept, then you must not include the work done by the gravitational force. If you think about it very carefully, then you realize that the concept of GPE is invented just so that we do not have to calculate the work done by the gravitational force. Get it? Okay, ta-ta!